Morning again, fuckers. How are we? God, getting some hours in, aren't we? As a neutral earther, there is something I have to point out. I hear a lot of the flat earthers saying, how can the sun and the moon be in the sky at the same time? It doesn't make any sense. Well, remember, don't take sides. There's the moon, right? So we can see the top of it, can't we? Right, and over here, El Sol, the sun. Now, you can't see them both. You shouldn't be able to see the both of them in the sky at the same time. That's kind of wrong. Right, where's it gone? Right, it's doing that bit. There we go. Right. You can. Now, the reason for this, now remember, like I said, I'm in the middle. I'm not gonna take sides on one. Something like this, people say, no, it can't be. Of course it can be, right? So what you have, don't forget, they're saying 150 million kilometers. So Earth, and we've got the moon up there, and the sun up there. So if I turn it like this, right, and come this way, what we have is Earth, we're here, so I'm going to do it down here, right? Oh, God, look at all that water. It's leaking. And then we have the moon. Don't forget, the moon is only, I say it now, I'm saying only, it is 30 Earth diameters away from us. So, look, I'll put it right at the outer limits. Okay, that's the moon. Now, the sun, it's over that way, but it is, look, they're saying it's 150 million kilometers away. So we just looked that way, we saw the moon, and then I looked this way, and we saw the sun. But what you need to understand is the sun, are we zoomed in? Oh, the sun, if it is 150 million kilometers away, if it is 108 diameters of itself away from us, it will be like so, I mean, beyond that, beyond, don't forget, 108 sun diameters between Earth and the sun. There are 109 Earth diameters in the sun's diameter. So Earth diameters, that's 109 multiplied by 108. 100 by 100 is 10,000. The sun is over 10,000 Earth diameters away from Earth, right? And we are basically together when compared to the sun. So with the sun way over there, right? Way over there, it's so far away that when it shines, it does shine on the top of the moon. And we kind of see the bottom of it in shadow. But that is because the sun is so far away. So it is perfectly logical, if it is 150 million kilometers away, to see both the sun and the moon in the sky at the same time. All right? That's me being perfectly neutral. All right? I'm not going to diss one for the other. I hear loads of people saying that, and I can never work it out. Why wouldn't you be able to see the moon and the sun? I get the flat earth. You're saying that that is close to the moon. But when the moon eclipses the sun, it's basically just behind it, right? Look, I don't know all of the dynamics behind the flat Earth, so I'm not going to comment either way until I'm properly clued up on it. But the thing is, there is one thing that is 100%. The moon does not affect any of the water on this planet. It has nothing to do with the tides. Folks, I can understand that it's being taught, but you must look at the evidence. Number one, Earth has a diameter of 12,742 kilometers. The moon, 3,474. Earth is 3.6 times bigger than the moon. Now, you've got two objects with those dimensions next to each other. It's not an equal pull at all, right? The Earth is hardly going to budge. If the moon was attracted and wanted to pull Earth, it's going to pull itself towards Earth, right? It's not going to bulge water out, pull the planet out and create a back bulge. Convenient for the tides. No, it doesn't. It's not big enough. It's 30 Earth diameters away from us. Ridiculous. Something else. It's supposedly orbiting the equator, right? These are the things. Again, I'm being perfectly objective. If it's orbiting the equator, you would expect the crazy tides to be here. It's common sense. You don't get massive tides all the way up. What? It's about 50 degrees, isn't it? Up here. That's the 30 degree. That's 60. So yeah. And there's 4 of them. I mean, come on, right? It doesn't make any sense. You would not get those tides up there. And it's not about friggin' vectors or funneling effect. It's illogical. Then you have, if this powerhouse moon can really move Earth and bulges and yada yada, then it would move the lakes, the seas. Look, you've got these lakes right next to the biggest, the highest tides. It isn't logical. It's stupid to think that the moon is pulling the planet, bulges, but not leaving all of the water bodies as they are. It's, oh, God, it's just so common sense defying rubbish, right? And logic defying rubbish. It just is. Now, what else is there? There's a few things. Have I said them all? So we've got the size of Earth, the distance from moon to Earth. We have the tides all in the wrong places. The water bodies aren't moving, but it's pulling everything else. Look, the way that they're saying that it pulls on the planet, you'd be careful when you went to have a cup of tea or a drink of water, because the moon was there, wouldn't it? But it's not pulling on the bodies of water. Look. Science doesn't care about your common sense. These things, it just doesn't work. If it's doing one, it should be doing the other, right? So, straight away, the moon has nothing to do with any of the water movement on this planet. It's illogical. It doesn't matter what you've been taught. You have 3 or 4 solid reasons, right? Knowing that, it's not a gravitational pull that's happening. It's more of a water displacement. It's almost like there is mass being added somewhere, and the water rises and then it drops. Anybody who's fished in rivers, the incoming tide, it starts fairly slowly, that bottom hour, and then as it gets to the second hour, it speeds up, and then right in the middle, like you've got the half hour of the middle incoming, and then the half hour of the top of the middle incoming, and it gushes in, right? And then when it gets to that last hour where it's just coming to the top, it slows down a little bit. It's like, right, okay, we're full up. But then when it turns around and it starts to drop, it all happens. It's like a mirror image of what happened when it was incoming. It slowly starts to drop, and then it just goes boom. And look, you wouldn't be able to swim against the current when it's coming in or when it's dropping. And then as it gets to near that last hour and a half hour of the outgoing tide, it just seems to slow down again, and then slowly comes back. Now, if it were a gravitational force pulling on the water, would you really expect that when it got to the high tide for everything to play out exactly the same as it did when it was coming in? You'd think that the moon would kind of hold on to the water because it's just pulled it, it's just been the attractor, and it's still up there. So you'd think it would, I don't want to let it go. And it might be a little bit slower because of a gravitational force, but it doesn't ever play out like that. It comes in, slow, speeds up, slows down. And then on the outgoing, slow, it speeds up just the same, and boom, then slows down at the very end. That is not a sign of a force that is pulling. That is a sign of a water displacement. Like in a bathtub, somebody's pumping water in through the plug, a certain amount of water in it, and then they pull the plug, stop, and then it's almost like the planet is, I say planet, breathing. It's not a gravitational pull, it's more of a water displacement push, I think. So, look, I was just being objective about people saying, no, you can't see the moon and the sun in the sky. You can. With the round earth analogy, you can. Because the sun is that far away that it does shine on the top. If you look, right, you can see, where is it? I can't see anything here because of the sun. Where is it? Ah, hang on, let me get my bearings. So I've got that cloud there, and so it should be about there. And I think, can you see it? Because I can't. It's just the sun. It's that bright out here. But it's got to be there. I think I can see it. There's that little dip, and there's that cloud, so it's above there. Right, it's there. There it is. Now, as you can see, it's almost like, I hate to say it, it's like that blue marble. It's the blue marble, bitch. They took it from freaking Earth. It's the moon. But we're seeing like the top, aren't we? The top kind of half. Now, if we turn around, right directly, right? 1, 2, 3. See? It's in line, but it's so far away, 150 million kilometers, that it's so high. Right? So it would shine down like it is, and we would see the moon as we're seeing it. That's all I'm saying, okay? I'm being perfectly objective. All right, 14 minutes again. All right, folks, have a great Saturday. I'll probably be back for something. All right, later.